Hi girls, I'm just going to take a look now at the next section in terms of maths. So we're taking a look at distance, speed and time. Most of this is probably already covered in your science class, but I'll just go through a couple of questions and examples, I'll give you a couple, and then we have one more section in this chapter and we'll be finished it on Tuesday. Okay, so this is the triangle that we use to do calculations with distance, speed and time. So I've always learned a daddy's silly triangle. How you work it is, if you're looking to work distance, then you cover over distance and you see it's speed multiplied by time. If you want to work out speed, it's distance divided by time. And if you want time, it's distance divided by speed. So these formulas in this triangle should be at the top of your page when you're doing any calculations along the lines of distance, speed and time. The next thing to take a look at is the word accelerate, which is important for you to make sure you know that the word accelerate means to speed up. So that's when you're getting faster. Most of the questions that I've seen in terms of mocks and the exam papers all have graphs with them. So we'll take a look quickly at a couple of very simple ones in terms of regular distance, speed and time. But most of it is stuff where you would be asked to draw some sort of a graph or make some sort of a discussion about a graph. So for example, if we take a look at page 353, so that's where all the questions are, 353 and 355. If I just take a look at question 9, for example. So question 9 says, after a meal, an earthworm moves the distance of 45 centimetres in 90 seconds. Find the average speed per hour of the earthworm. So again, not the most exciting of questions, I suppose, to do with distance, speed and time, but it's how you go about taking a look at it. So they have given us a distance, and they've told us the distance is 45 centimetres, and they've given us a time, and they told me the time was 90 seconds. They've asked me to work out the speed, so speed is distance divided by time, but the only thing they've asked me to do is find the average speed, but they've asked it per hour. So before we start, we need to change these 90 seconds from seconds into hours. So how do we change seconds into hours? Well, you can't go directly from seconds to hours. You're going to go seconds to minutes. So if you take a look at that, you're going to divide it by 60. Why 60? Because there's 60 seconds in a minute. And then you're going to divide it again by 60 because there are 60 seconds in a minute and there are 60 minutes in an hour. And that's going to get you your answer in an hour. And that's going to be a very small number that you're taking a look at. So we're at 90 seconds and we're divided by 60 and divided by 60. And it's 1 over 40. And we tend not to use the fraction, so 0.025. And that's in hours now. 0.025, and that's in hours. So now we can sub into our formula. So it's 45 centimetres and it's divided by 0.025 hours, and that goes into calculator 0.25, and you get 1800 centimetres per hour. And this line here means per, so you can either write the slash or you can go per, whichever you prefer. Okay, they mean the same thing. For nearly all maths questions though, to be honest, units are not a huge deal, so I'm not going to stress about them. So that's how you use the triangle. This one is looking for speed, but it's the same method depending which one they're taking a look at. All of the questions are roughly the same. You will have some conversions, so you might be asked, like I say, in terms of, like we did here, instead of seconds, they wanted in hours. You're best to do those changes before you start the question. So if you could do them before you start the questions, it'll make your life a little bit easier, and they'll also bring some of the time together again that you were doing in the past examples for me, and you didn't have any difficulties with them. So I don't expect you to have any problems with them. So to get you started then, it's page 353, and we'll say 11, 12, 13, 14 and 15. So we'll say 11 to 15 is the first part of the work. And then the major part, like I say, is taking a look at these graphs and what each graph means. So if you take a look in your book at page 351, they give you examples of both types of graphs, or the major types of graphs that you might be taking a look at. So for example, if you look at this particular graph here, and you'll see it in the exam papers when we come on and take a look at it, or in a mock paper if I have to find a sample for you. these are the type of graphs you see quite often. So what are you looking at? Well, before you start, you take a look at your axis. So your x-axis is the time, so that's how long it's taking us to travel somewhere, and this one is the distance from the starting point. So the starting point then is down here at this point here. So that's wherever you're starting from. So it's best if you can kind of think of it in terms of a little story. So let's say you're going to, well, we wish we were going to school, and we were taking a look, and you've got a little house, and you know I'm a wonderful drawer, girls, so there's my little house. That's the starting point. And you leave your house, and it takes you a certain length of time to get somewhere. Okay, so this somewhere here happens to be the school. And again, if I try to draw it, it's just going to look the same. So there's your school, and then you're not travelling anywhere, so you're going nowhere. So you're staying in the same place for this amount of time. Okay, so you're in school for, we'd say, 6 or 8 hours, and then you take a look at, afterwards, you're coming back to your starting point, so you're back to your house. So if you're asked to discuss the graph, you can see that there's 3 particular parts. There's one, which is you accelerating and moving at a constant speed. Now, how do I know it's at a constant speed? Well, I know I'm going at a constant speed because that line's straight. Okay, so it's at a constant speed, I'm travelling towards something. Then I get to the place, I stay there for a certain period of time, so I'm not moving. So section 2 is I'm not moving. And then section 3, I am moving. And again, I know I'm going at a constant speed because this is a straight line. Now, because line 1 and line 3 are straight lines like you see down here, you're going to be expected to do everything that you did with coordinate geometry with this particular section. So, for example, if you know that you're starting here at 0, 0, and you know this point is 2, 4, for example, you could be asked the distance, and that would be using the distance formula. You could be asked, like they're showing you down here in the sample, to work out the slope of this line. So you'd be working out your rise and your run, like you did for coordinate geometry. And that's pretty much what you're going to be taking a look at. So again, if you come across and you take a look, that example there, example 6 is quite a good example as well of what we're talking about. But here's one here with a cheetah chasing. I don't know what he's trying to eat. Okay, the cheetah, a springbok. Okay, I'm not even really sure what that is, but anyway, again, you're starting here at a certain amount of time, so he's slowly starting to run and move a distance, and then all of a sudden he speeds up. But again, it's a constant speed, and he's trying to get to somewhere. He stops, then he slows down, he goes back towards where he started, and then he speeds up again, he stops, and then he goes back to where he started. And that's what they're asking you to do. What they're asking you to do is discuss that graph like I've just discussed with you. So that's what those sort of type of questions they're going to take a look at. They are a little bit harder. Most of you will have done some of them in terms of science, and that's, for example, this one. So I'm going to give you the more relevant ones, the ones that you would take a look at more often. So that's going to be page 355, question 29 and 31. So you're going to try those ones for me. It's no point in doing too many of them, because if you're doing them wrong, then we need to figure it before you try any more of them. So you're going to take, so back over here, you're going to take, and I'll put this up on Edmodo for you anyway, 29 and 31. And the due date then for that, girls, is, I'll put this up now. This is Monday's work, so it's due on Tuesday morning. The same idea, comment underneath it. If for whatever reason, and there's a couple of you who've come to me and you've had particular difficulties in terms of logging in, you can email me then or private message me, but it should go under as a comment under the assignment, because otherwise it's very, very hard for me to know who has handed it up and who hasn't. And this week, if people aren't responding to Edmodo, I have to let senior management in the school know that you're having difficulties. So I don't want to get somebody in bother. If you can do it, send it to me as a comment, and if you can't do it, then email me. You have my email address, rather than me going to senior management, then them contacting you, and it turns out it was just you couldn't log on. So I'm having difficulties with Edmodo every now and then when Wi-Fi breaks or Wi-Fi goes down, and I'm sure you're having the same issues. So if that's an issue, just email me. But other than that, if you can just leave a comment in underneath the assignment. Alright, girls, I'll be back on then on Tuesday with the answers to those questions once you've all submitted, and we'll move on to the last part of the chapter, and I'll talk to you then. Take care.